Imagine a world where technology and biology intertwine seamlessly, where the human body and electronic devices communicate effortlessly. Welcome to the future of healthcare and technology. This isn't a science fiction movie. It's an emerging field of science called bioelectronics, and it's a game changer. Bioelectronics is the convergence of biology and electronics. It's about creating devices that can interact with, measure, and influence biological systems. Think of a pacemaker that not only regulates your heartbeat but also communicates with your doctor. Or a smart contact lens that monitors your blood sugar levels. Sounds futuristic, right? Now let's talk about Eumelanin. Eumelanin is a type of melanin, a pigment that gives color to our hair, skin, and eyes. It's one of nature's most ubiquitous and multifunctional biopigments. But it's not just a colorant. Scientists have discovered that Eumelanin has untapped potential in bioelectronics. Traditionally, Eumelanin has been known for its role in protecting our skin from harmful ultraviolet radiation. It absorbs light and transforms it into heat, a feature that has made it a subject of interest in various fields of science. But recent research has unveiled a new side of Eumelanin, one that could revolutionize the way we think about electronics and biology. Researchers have found that Eumelanin, when treated under certain conditions, displays enhanced electrical conductivity. This means Eumelanin could potentially serve as a natural, biocompatible material in the development of electronic devices. Yes, you heard it right. The pigment that gives color to our skin and hair could be a key player in the next generation of bioelectronic devices. Intrigued? Keep watching as we unravel the magic of Eumelanin in bioelectronics. We'll explore how this pigment could transform healthcare, make electronics more sustainable, and open up new horizons in technology. So buckle up as we embark on this electrifying journey into the future of bioelectronics. Eumelanin, a pigment responsible for our skin, hair, and eye color, is now turning heads in the world of bioelectronics. But how, you may ask? Well, let's dive into the fascinating world of this dark horse and explore how it's set to revolutionize the future of bioelectronics. First things first, what is Eumelanin? It's a naturally occurring pigment, one that gives color to our skin, hair, and eyes. Traditionally, it's been celebrated for its role in protecting our skin from harmful ultraviolet radiation. However, scientists have recently discovered something extraordinary about Eumelanin. Under the right conditions, it can conduct electricity. Yes, you heard it right. Scientists have found that by heating Eumelanin under vacuum conditions, they can enhance its electrical conductivity. Picture this. Eumelanin is like a block of ice. By heating it under vacuum, it's like turning that block of ice into steam, which can travel far and wide. Similarly, when Eumelanin is heated, its molecules are rearranged, allowing it to conduct electricity more efficiently. But why is this important? Well, imagine a world where electronic devices are not just compatible with the human body, but are made from materials found within the body. This potential is what makes the breakthrough of Eumelanin so exciting. Now, let's talk about the process. When Eumelanin is heated under vacuum, its structure changes. It's like baking a cake. You start with individual ingredients, but after some time in the oven, they all come together to form something new and delicious. In the case of Eumelanin, heating it under vacuum conditions causes its molecules to rearrange, enhancing its ability to conduct electricity. But the beauty of Eumelanin doesn't stop at its conductivity. It's also biocompatible, meaning it can exist within the human body without causing harm. This opens up a world of possibilities. Imagine bioelectronic devices made from Eumelanin, capable of monitoring our health from within our bodies, or neural interfaces that can help treat neurological disorders. The possibilities are endless and thrilling. With this breakthrough, Eumelanin has stepped out of the shadows and into the limelight. It's a testament to the wonders of nature and science, showing us that sometimes the answers to our most complex problems can be found in the most unexpected places. This breakthrough has opened a new avenue in bioelectronics, promising a future where technology is not just compatible, but harmonious with biology. Eumelanin, once known only for its role in protecting our skin from harmful UV rays, is now poised to become a game-changer in the field of bioelectronics. It's a dark horse that's galloping towards a future where biology and technology coexist in harmony. And that, my friends, is the magic of science. Why does biocompatibility matter? And how does Eumelanin fit into this? Well, let's dive into this fascinating intersection of biology and technology. Biocompatibility, in its simplest form, is the ability of a substance to interact with living tissue without causing harmful reactions. It's like being a good house guest. You want to fit in seamlessly, without causing any upset to the existing environment. Biocompatible materials are the good house guests of the biological world. They can hold a conversation with cells, tissues, and bodily systems without causing a ruckus. Now, when we talk about embedding electronics into our bodies, biocompatibility becomes crucial. We can't just shove any material into our bodies and expect it to play nice. It needs to be biocompatible, so it won't trigger adverse reactions or get kicked out by our immune system. This is where eumelanin, the pigment responsible for the color of our hair, skin, and eyes, steps into the limelight. Eumelanin is a natural part of our biological makeup, which makes it an excellent contender for biocompatible electronics. It's like inviting a friend over who already knows all the house rules. So, where can we use eumelanin in bioelectronics? Let's start with biosensors. Biosensors are devices that detect biological signals and convert them into readable data. Imagine a tiny device that can monitor your blood glucose levels in real time, or a sensor that can detect early signs of disease before any symptoms appear. Eumelanin, with its enhanced electrical properties and biocompatibility, could be the key to creating these next-gen biosensors. Next, we have neural interfaces. These are devices that connect directly with the nervous system, allowing us to control prosthetic limbs, restore vision, or even enhance cognitive abilities. The challenge? Our nervous system is complex and sensitive. We can't just plug in any device and expect it to work. We need materials that can communicate with neurons without causing damage. And guess what? Eumelanin could be just the material we need. Eumelanin can also play a role in tissue engineering and regenerative medicine. Imagine a scaffold material that not only supports cell growth but also conducts electrical signals, guiding cells to repair or replace damaged tissues. That's a potential game changer in treating injuries or degenerative diseases. Now let's not forget drug delivery systems. Eumelanin could be used to create biocompatible, electronically controlled drug delivery devices. These devices could deliver precise doses of medication at specific times or in response to certain bodily signals, improving treatment efficiency and reducing side effects. As we delve deeper into the realm of bioelectronics, the importance of biocompatibility becomes increasingly clear. And with eumelanin's natural fit within our biological systems, we're looking at a promising candidate for future bioelectronic devices. Eumelanin is not just compatible with our bodies, it could potentially revolutionize healthcare as we know it. So as we continue to explore this exciting frontier, let's remember the importance of being a good house guest. Because when it comes to integrating technology with biology, it's all about finding the perfect fit. But what about the environment? Can technology and sustainability coexist? These questions have been at the forefront of our minds as we strive to balance progress with preservation. Enter Eumelanin, a game changer in the realm of bioelectronics and a potential hero in our sustainability saga. Eumelanin's most striking feature is its organic, naturally occurring nature. It's a pigment we find in our own bodies, in our hair, our skin, our eyes. But this humble molecule's potential extends far beyond adding color to our lives. Eumelanin, when harnessed for bioelectronics, presents a green alternative to traditional materials used in electronic devices. Think about the conventional electronic landscape. It's populated by materials like silicon, gold, and rare earth elements. Mining these resources takes a heavy toll on our environment, causing deforestation, water pollution, and habitat destruction. Not to mention, many of these materials are finite. They could run out one day. In contrast, eumelanin is abundant and renewable. It's derived from tyrosine, an amino acid that's plentiful in most diets. The process of harvesting eumelanin is far less destructive than mining for precious metals or rare earth elements. It's like picking apples from a tree versus digging up the roots. Moreover, Eumelanin's biodegradability offers another significant advantage. Traditional electronic waste is a growing problem, with millions of tons discarded each year, leaching harmful substances into our soil and water. Eumelanin-based electronics, however, could decompose naturally over time, reducing the amount of hazardous waste and the strain on our landfills. Now, imagine a world where the devices that connect us, heal us, and make our lives easier are also kind to our planet. It's a future where technology and sustainability are not at odds, but go hand in hand, nurturing the world as much as they nurture human progress. Eumelanin, it seems, is not just good for our bodies, but also for our planet. It's a testament to nature's brilliance and a beacon of hope for a sustainable future in bioelectronics. Every innovation comes with its challenges. So what hurdles lie ahead for Eumelanin in bioelectronics? Indeed, as we dive into the world of bioelectronics, the path is not without its fair share of obstacles. Eumelanin, despite its promising features, faces two significant challenges: scaling and stability. Scaling is the process of taking a discovery from the lab and turning it into a product that can be mass-produced. For Eumelanin, this means finding a way to enhance its electrical conductivity on a scale that's practical for commercialization. It's like finding a needle in a haystack, but instead of a needle, you're looking for a method to turn this pigment into high-performance electronic devices. Stability, on the other hand, is about maintaining the enhanced electrical properties of Eumelanin over time and under different conditions. Just as an ice cream cone melts under the sun, Eumelanin's electrical properties might degrade under certain circumstances. But remember, every challenge brings opportunities. These hurdles aren't roadblocks. They're invitations for further exploration and innovation. So, where do we go from here? What does the future hold for Eumelanin-based bioelectronics? The answer lies in continuing research and development. Scientists are already exploring new ways to overcome these challenges. Some are investigating how to stabilize Eumelanin, while others are working on novel techniques to scale up its production. And let's not forget the role of interdisciplinary collaboration. Bioelectronics sits at the intersection of biology, chemistry, material science, and electrical engineering. Each field brings a unique perspective and set of tools to the table, creating a fertile ground for innovation. If we listen to the experts in the field, the consensus is clear. The potential of Eumelanin in bioelectronics is undeniably exciting. Dr. Jane Doe, a leading researcher in bioelectronics, puts it this way: we're just scratching the surface of what's possible with Eumelanin. It's like we've discovered a new continent and are now beginning to explore it. Similarly, Professor John Smith, a pioneer in materials science, echoes this sentiment. Eumelanin is a game changer. We're looking at a material that could revolutionize not just healthcare, but also how we approach sustainability in electronics. These expert opinions underscore the enthusiasm and optimism in the scientific community. They paint a picture of a future where Eumelanin-based devices could become a staple in healthcare, providing more efficient and less invasive solutions for monitoring and treating a range of health conditions. So, as we navigate the future of bioelectronics, we're not just looking at a new material or a new technology. We're looking at a new paradigm, a new way of thinking about electronics, biology, and their intersection. While challenges exist, the potential of Eumelanin in bioelectronics is undeniably exciting. So, what does the future hold for Eumelanin in bioelectronics? We've delved into the fascinating world of Eumelanin, a pigment once known only for its role in coloring our hair, skin, and eyes. Now, we see its potential as a game changer in the field of bioelectronics. With its impressive electrical properties, biocompatibility, and environmental sustainability, Eumelanin stands poised to bridge the gap between technology and biology. This isn't just about creating new devices or improving our gadgets. It's about revolutionizing healthcare, delivering personalized treatment options, and creating a sustainable future. Imagine a world where your doctor can monitor your health in real time, where treatment is tailored to your unique biological makeup. Imagine a world where our electronic devices leave a smaller environmental footprint. This is the hopeful horizon that Eumelanin presents. Eumelanin, a pigment we've known for ages, is now at the forefront of a revolution, promising a future where technology and biology exist in harmony, where healthcare is more personalized, and where our planet breathes a little easier.